Hello,
Hello,
Internet.
Max. Hello, Internet. Hello, chat. Hello, Gnarly.
Hello,
Adam H. Greetings.
hello, chat.
Hi there. Hi, Tom. Hello, Oscar. Hello, everyone. Hello, Stream Elements.
Stream Elements. Let's go.
Hello, Urban.
My trusty Stream Elements.
Welcome to another Effect Office Hours. I'll do the intro. As this is still a relatively new thing, though. What is this? The 8th, the 7th, the 6th? I've lost. This is the 6th Office Hours in a row. So that's pretty impressive. So housekeeping. Next week we're going to try doing this a little earlier at 10 a.m. PST, which would be, I believe, 5 hours before now. This is because of Sam Rose, if you know that person from Twitter. They are a very prodigious author of interactive visual pedagogy of various sorts. They have a website called samwho.dev with all sorts of great visualizations on like load balancing and memory allocation. It's very cool. But he lives in the UK, and he pinged me on Twitter and said, "Hey, this is too late for me. I've got kids. What are you doing?" And so I thought maybe if we try 10 a.m., that might technically work for most of the continental US, and then also our friends in Europe a little better. And we'll try that. And then if the San Francisco people say, "Hey, it's 7 a.m., that's really early for San Francisco people," then we'll try to negotiate. But we're trying 10 a.m. next Wednesday. And maybe even Sam will call in and ask us some questions about Effect, which would be fun. He's a great guy. So yeah, there's that. Cool. Now we have slightly more people here. So I think I just wanted to start with, we have some questions in the Discord. And of course, as always, it's preferable if people want to call in. You can queue up with a phone call, but we have some sort of smaller questions that I want to get to as well in the Discord. I think we can answer pretty quickly. But I wanted to start with a little example, because I prepared something and want to show it off. So let's see if this works. I'm going to share my screen. This is going to be on context, Effect context. I think we can do this. My goal will be to do this in less than 15 minutes, maybe less than 10 minutes. And we'll see if my ability to estimate times is broken like most programmers or not. So slide effect. Let me know, can everyone see this?
I can see it.
Cool. Is it too small, too big? Let me bump it up one. I might have to adjust this. So yeah. Oh, RJ, you're back with the Confect example. Amazing. Okay, yes. We should get to that after this. So I'll run through this very quickly, and we'll save I think at least a half an hour for that, because that's a big juicy question. So maybe I'll run through this as quickly as humanly possible, and then maybe quickly answer some of the smaller Discord questions, and then we'll bring you in. That'd be amazing. So yeah, I want to talk about two things, which is how do layers work? Sort of take a look at the implementation detail known as context, which is a type-safe heterogeneous map, which is a fancy little confluence of adjectives. So we'll talk about that in a moment. But first, some motivation as to like why you might even want to use that. So first, like the simplest option, and if this always worked, wouldn't this be great? Like these are the ergonomics we want. We have this little app here where there's some main function called process user. We get a user and then we welcome the user. So pretty high level, reads like pseudocode, very high level of abstraction. If we look into the welcome helper function, it's kind of arbitrary to pull this out, but whatever we did, we send off some analytic event tracking that we send a welcome email, and then we send off an email to the user. So very high level. But if we think about how this must be implemented, users events mailer, if we're not using the layers stuff from Effect, then these would have to sort of be global singletons, essentially. And I can run this program, and we'll see that, we got user one, then we sent a tracking event that were sent a welcome email, and then we actually sent the email to them. And these are like live services. one could imagine. We see them running one after the other, and it's pretty, and it takes a second, approximately. And this is great. It's really easy to just structure your programs like this because you can reach into these globally defined services and use them. However, this actually sucks in practice because you cannot swap the implementations. You're referencing a global singleton. So for instance, this events is just being hard-coded and referenced here. So yes, it's great for the live production use case, but everything else is kind of unhappy when you want to test this. You want to be able to swap it out. So what can you do? Well, the most naive and simplest, and honestly, not a terrible approach, someone asked about this actually on the Discord, I believe, is why not just use function parameters? Right? Just pass it in as a parameter and code to an interface instead of sort of the concrete implementation. So we'll just thread events here. So notice it went from uppercase events to lowercase events, and we added it as a parameter. And then, of course, in order to call welcome, it's now missing its events argument. So we'll need to do recurse and propagate it and basically continuously propagate it, working our way back up to the top of the program where we can then pick an actual implementation. And in production, we can pick a live implementation, and in testing, we can pick a test implementation. Of course, this gets very verbose. I'm going to extend it to everything. So if we do everything like this, I'll make it smaller. Now every function has to track and accept everything that it uses, and it also has to accept everything that any sub method will use. Oh, it looks like this got a little screwed up there, but yeah, it's not so ideal. So that got a lot uglier. That's kind of one of the downsides of this is that it just gets very gnarly and ugly when you do parameter propagation. The other downside is right now I'm passing in events live. I'm sort of assuming that this is still a pretty simple service that doesn't have transitive dependencies. But if it did, this events live would be more of a function that you would have to, or maybe a class constructor that would take its own dependencies. And some of those dependencies might need to be acquired asynchronously, or they might be resourceful. So you wouldn't just be able to pass in events live here. You would further need to have some other kind of boot setup system initialization logic that can get really gnarly, especially when you have a whole bunch of services. And what you end up what you end up having in practice a lot of the time is just this huge main init file that always grows and is very hard to maintain because if you have 10 developers all working on the same project and they're adding dependencies to various services, maybe that service is nicely factored and nestled in a submodule or whatever. Well, when it comes to the main, every time they change what dependencies a service needs, they're going to have to change that main file and thread it through. And once again, if it's a resourceful dependency, transitive dependency, or if it is asynchronous, they're going to have to thread it through in the right place. And the whole program can get very hairy, and that main file can be prone to very churny and have a lot of merge conflicts, which is not fun. So this is sort of the pain of this approach, which otherwise is conceptually very simple, just uses functions and parameters, which is ideal in some way, but ends up creating a lot of syntactic noise and then this big churny main function. Anyway, that's enough with this visual example. I wanted to very quickly, once again, so I don't know how long that took, but I want to share now a code example to quickly implement a piece of this from scratch. So here, download the weird new cursor. I'm not going to use this agents thing. Let me know if this makes sense. Yeah, prop drilling is a fancier. That's what the kids on the street. That's the street name for it. Prop drilling. So yes, here is an example of that sort of global singleton pattern where we can just refer to some live implementations globally, and it's really nice to write your code in production. But the second you want to test it, you really can't. So you're sort of doomed. And then you have the parameter threading model, which gets very verbose very quickly. And this is even simpler than it would be in production because these are kind of just the dependency-less variants that in the real world what might be incredibly nested. And you would have to initialize that in program. So what we're not going to work all the way up to layer, but we're going to sort of show what the underlying, what undergirds layer, what powers layer, which is this idea of something called a context. And what a context is, well, I mean, the simplest version of it would be, yes, like a private, basically a map. I'm just going to construct this very quickly. So it's just for now. It's just going to be a map from string to any. This is going to be we're going to start with a really shitty implementation, and then we're going to slowly, step by step, make this type safe and get all of the benefits most of the benefits that we will from using the sort of the service pattern in effect here. So the idea is, instead of propagating each of these individual services everywhere, what if we just propagated one parameter called a context? And of course, this is still kind of ugly. We're propagating this parameter everywhere. The magic in effect that we're not going to get to here is that this is automatically propagated for you. There is some context class, but it's automatically propagated for you by the effect runtime. So every effect that runs has access to some in-scope context. So we can delete this other parameter as well in the final implementation of effect. But let's sort of build our way up to having this context map. So we have this map from string to any to start with. So yeah, we can construct it with a string to any. We're going to have a static empty here, which is going to be an empty context, and then we're going to have an add function, which actually isn't going to be typed at this point. It's just going to take an any. It's going to be sort of immutable. So we're going to create a new map. So this is going to return a new context. We're sort of generating a nice immutable data type here, sort of, or simulating one. So when you add a key and a value to the context, it gets you back a new context where that value is stored at that key. So we've really just made a weird sort of immutable wrapper around a map for now. We're going to iterate on this. That's why I sort of wrapped it in a class, but whatever. Okay, so now we have this context and we no longer have a user service. So how would we get the user service? Well, yes, we're going to do the following. We're going to pull the user service out of the map. And of course, it comes back as an any, so we're going to cast it. Clearly, that's not type safe, but so be it. And then instead of pulling out analytics and mailer, we're just going to propagate our context down to welcome. And then welcome will also accept a context. And before it will pull out its analytics and mailer. And then at the top of the program, we're going to construct one of these contexts and add our implementations to it, and then just propagate that along. This clearly has many problems, but it does work. I can run this program, I believe. Let me cancel this other one, and we should see yes. So there's a test implementation of the user service, a live implementation of analytics, and a live implementation of mailer. There's unfortunately 1,000 ways this can go wrong, right? I mean, first of all, let me show you that I can swap inversions at the top level, just like I could with the parameter prop drilling variant here. And so now that says it's using the live service. But how can I screw this up? Well, one is I can just have a typo anywhere. These are string keys. So if I just try to get analytic, undefined is not an object, evaluating analytics.track. So that stinks. Or I can, pull out the wrong service. And then, yes, of course, analytics is not .track is not a function on the mailer data type that we pulled in. So those are two issues. And then, of course, we're sort of manually having to type things here. We can accidentally, maybe we get a key right, but we accidentally type this as mailer, whatever. I mean, that's just a lie. And so now analytics won't work here. But yeah, what if we screwed this up and did analytics and then sort of swapped, this is crazy, but mailer.track and analytics.track. This is all type checks, but it's totally wrong. It's totally broken. So there's not really any type safety to this at all. It's just this weird map we're passing around. So let me go back to doing this. It would be nice if this were type safe. That's kind of the next level of this. So this is not an untype safe map, type unsafe map. So what I said before is that a real context, a context is a type safe heterogeneous map. Sure. So under the hood, though, it's basically going to be a map like this. This works. Clearly, it works. It's just it's not type safe, right? So it's runtime safe if you call it correctly. The nice thing about a very popular pattern or a very common pattern in effect and in these type safe libraries is that the core implementation at some point wrapped up in type safe interfaces will be unsafe code, just because that will be faster or more convenient, or at some point, like, you just have to write it that way. The type safety is just through sort of making it correct by construction, only exposing a certain number of interfaces that enforce types, and then all the details, the messy innards can be just sloshy and sloppy, and you can just do open heart surgery with rusty knives. But on the outside, all that's boxed away and hidden from the end user. So they don't really know how revolting your library is on the inside. The effect actually does have some very beautiful code. Okay, so how do we migrate towards this? Well, let's just go one step at a time. We need some kind of type here. Maybe we could just say there's some T here, and we want to get back to T. And so we can just sort of cast this as a T. We don't really have to because it's an any, so it'll just automatically cast. But that'll simplify this a little bit. Maybe we can just do this now. Specify the types here. It doesn't really matter. It's literally the same thing, except the casting is kind of done internally. But if we do this, and we also sort of take the type parameter here, we can add a type to our context type. So this is sort of the big fancy trick, is that context has this phantom type parameter called services. And I'm going to use this in keyword here, which maybe we could talk about some other time. And this services only exists at the type level, which is why it's known as a phantom type parameter. It's basically just used to track service 1 is in the map, service 2 is in the map, service 3 is in the map, etc. So it's going to, in practice, be this union type that's really sort of just like a type level set to mark which services should be in this map. Of course, in practice, they're going to be any, but you should know that if you have a context that has a user service, so if you have something like context users, analytics mailer, that ideally in this map, there exists some implementation of users, analytics, and mailer. And so how do we enforce that? Well, when you add a service to the map, you're going to just sort of typecast it here as it's going to be services unioned with the T. And so what is this going to do? Well, a couple of things. Firstly, we'll go to this call to welcome, and we'll say, well, what do we need here? Well, we need an analytics and a mailer. That's what we use. So we need analytics and mailer. And already, actually, I believe if I fix this, let's just say this just has user service. So this uses a user service. So already we get a type error here. Argument of user service is not assignable to type parameter of context, analytics, and mailer. So we already have some amount of type safety, even though it's kind of fake and hacky here, which is that this needs to know that we have all of these services in it. So analytics and mailer. And now it type checks. Hooray. So just by doing that, we get some safety at the type level. And unfortunately, this says context unknown. Did I thread this through correctly? I might not have. Value T. Is that because, oh yes, because this isn't, let me try to actually annotate this. User service, analytics and mailer. Will this know its type? I might be screwing something up. It still says type unknown. Oh yes, because empty. I did not type empty. This has to be a context of never as well. So I believe that's the cause. And yes, so now this correctly figures out, or infers rather, the types that are used. So that'll correctly propagate upwards just by calling these things here, which is pretty nice. So there's some amount of type safety, kind of. If I go to get something, what'll happen actually if I go to get something? Let's try to get an int from this. Call it number. What am I saying? Int. How stupid of me. Let's just try to get a number from this. Yes, so this is not type safe yet. So we need to make sure that this extends services. And that if we say this, what this is going to do is it's going to say, hey, number does not satisfy the constraint analytics or mailer. So now we'll also get this additional layer of type safety when we attempt to access a value and implementation out of the context. So this will force us to, if we want to do this, to represent it in the type here. And then now there's a type error here. It'll propagate up to the top of your program. And then, of course, in order to actually fulfill this, we'll have to then come here and add a number. And that'll work, which is kind of cool. So it's actually not faking it at this point. Not too much. But there is a bit of a problem. Let me remove the number. Example, no, I do want to keep extend services and then just delete this. So we have some amount of type safety on this interface. The problem, though, is that still we can just lie. We can just it's still stringly typed. So I can run this and it will fail. There's a type and there's a string, and these are totally disjointed from one another. What we need is something to unify the string identifier and the interface together. And that is what a tag is. So we're going to come up here and make something called a tag. And so it's going to have a string value, which is going to be basically the key of our map. And it's going to have a phantom type parameter, which will represent the interface. In real effect, there's sort of two type parameters that come into play here, but we're going to forget about that for now. It's kind of a detail. Maybe we can get back to that at the end if anyone's curious. But there's some other details that don't matter so much. They just add like the last 10% of polish to the library. This should be enough to sort of understand what's happening. So we have this tag, and then we need a way of constructing a tag. So let's see what this does. So yes, we're going to give a tag a type parameter and the string. So we're basically fusing together the type of the service and its identifier. So if we do this, now I can say something like user service is a tag of user service, analytics is a tag of analytics, and mailer is a tag for mailer. Cool. And so now instead of adding it under a string key, we're going to actually add it under with a tag. So instead of key, we'll say tag. And then, of course, we're going to get the tag's string value as the key. And then once again, instead of just using a key, we're going to access it with a tag and get the tag's value. So now we don't need to have this two-step process of both a type and a string key that might just sort of fall out of sync. Instead, we're going to use this tag value, which contains both the type and the string key. So already this is typed correctly. Because it knows that this user service is a tag of user service, this interface, and it has the string key inside. So as long as we add it with the same key in user service here, it will type correctly. So let me fix up these as well. So yeah, this knows that it's a context once again of user service, analytics, and mailer, and then we can fix this as well. So now everything is type safe, and we can run it, and it works. That's kind of it. That's the sort of the core of it. It is an unsafe map from string to any. And then there's a couple of challenges, which is to track the services at the type level, which we do with this contravariant type parameter, and sort of union together the types that are in the service, which we can see happens here. So I can make a new tag called, number tag. Number tag. I'm just not using that. And then I can add a number. Oops. Add a number 1. And now this will have in the type number. And it's going to look things up with that number key. I don't know why that's sad. Oh, global property number we're shadowing, whatever. I'll delete that. You get the idea. So yeah, the tag is just kind of this type that fuses together the runtime string key and the type level service so that it's harder to, they change together. And you can't pass in the wrong string for a given service, basically. Yeah. All right. Any questions? How did that make sense, Maxwell?
Yeah, I thought that was a pretty good explanation of why tags are in context that's designed the way it is. So there's
Cool.
a few other things that go along with this, but I think that's the crux of most of the questions of why people say why do we have to do it this way? Well, this is why.
Yes, this is why. And the details would be that, there are a few details, one of which is that we don't actually have to propagate this context. It's sort of done automatically for us. And that you seldom construct a context because this is kind of done in the internals of layers. But sometimes you can if you want to do something a little more advanced. But this is really what powers it. A layer is just a combination of a sort of an effect and a context. It's an effect that accepts a context and returns a context. In a hand-wavy sort of way. But I hope that helps a little bit. Yeah, let's stop doing this and talk to RJ. Hey, RJ, how's it going? Welcome back. I hope you had a good trip or traveling time or whatever it was.
Thank you. Thank you. Yeah, it was good. It was exhausting, and I got a little sick, so you might hear my throat's a little.
It's better raw for the radio. It's better for this. We're gonna get more views now. Yeah, it's gravitas.
Yeah, good,
Nice sultry voice.
Cool. Yes, good. I'd like to say maybe I need to maintain this level of sickness constantly throughout my life for the charm. I thought that was a great explanation also of context. I think it's really hard to understand that the motivation for the motivation for something like that, if you haven't tried to implement it,
it's
before,
a series of gotchas, a series of it's a series of pickles. So I hope I illustrated at least a few of like how you might stumble into that yourself. But it does get more complicated. But that would take an hour, and we would miss your incredible Confect work here. So
yeah. Well, we'll see. Maybe, I don't know. Maybe we'll touch on this throughout
awesome.
trying to solve my problem. So so I have some code we can look at. And so maybe we can. I guess maybe we should just.
You feel free to share if you want to, or if you don't want to, Maxwell or I could share. It's up to you.
I would love to. Well, I have it on my local editor here, so that's probably the best place.
Awesome.
I can find it in the share tab here.
Yawning, Maxwell.
Yeah, sleep is not hasn't been really a thing lately.
How old is your child? 2 days?
No.
1 month.
1 month.
2 days.
Yes.
Oh dear. Thank you for giving us your time.
Yes, absolutely.
All right, I'm going to share this. Okay, I'm going to have to zoom in. Maybe let's just make this one.
Maybe take it up one more, RJ.
Thing. Okay.
Cool.
Sure.
Does
that look right?
That's good. That's good. Oh, you want one down?
One down. Right. Yeah.
We'll see what the people say.
Okay. The sweet spot. Okay. All right. So let me try to reframe the problem I'm trying to solve here for folks who weren't here last week or who just don't remember the nuances of the problem that I was running into building this library that I'm building. So I'm trying to build a library for this this kind of like back-end, I guess, platform called Convex. And what I'm trying to do is, so it's like a serverless platform with a database as well. And so you create API endpoints at kind of as like Lambda functions, right? And they're exposed. It has a nice kind of CLI that will like generate the references to these functions, which you can then use to call them from your front end using like a React client, for example. And so you get it's basically the same sort of thing that you get with like excuse me, with like the Effect platform HTTP API modules or the RPC APIs. And so what I want to do is I basically want to have a version of this that allows. So the feature that I want to provide here is I want you to be able to. The library already does other things, but what I'm trying to add here is the ability to define these API endpoints in the way that you do with like RPC or the HTTP API library using effect schemas. So effect schemas for the arguments, for the parameters to these functions, and for the return values of these functions. And I'd like to generate a client or derive a client from some data structure, some API data structure that you create, which automatically does the decoding and encoding for you of the arguments and return values. Does that make sense so far?
Yep, tracking.
I can't see you guys.
Then we'll be more responsive. Yeah, we've just been shaking our heads and heads in our hands.
Okay.
No, it makes sense.
Good. Okay. You're feeling my plight. Good. So what I have here, so basically I'm trying to replicate the again, the RPC or sort of HTTP API APIs already do. I have an additional requirement here, which I've already accounted for, and I don't think is that essential to the problem I'm running into, but I want to explain it nonetheless, which is that I'd like you to be able to. So I actually don't know. I'm not as familiar with RPC APIs, but the HTTP API modules let you define your endpoints in groups, but they don't. It doesn't allow you to nest those groups. I'd like you to be able to arbitrarily nest groups so you can have a group that contains functions and a group that contains groups that contain functions and so on. And so I just wanted to point that out.
That makes sense. I mean, I don't know why HTTP doesn't. I wonder, I'm not sure if that's the source of pain or frustration. Maybe there's a reason why there's some Chesterton's fence, the fence, the guy's fence.
Yeah.
Don't take down the fence.
Yeah.
Yes, maybe he's like, Tim's fence. Tim Smart's fence says, don't nest groups or you'll die. But maybe that's not the problem.
Yeah. Well, I'm coming in here and I didn't ask Tim. I'm just tearing down his fence. So we'll see if it's a problem. Maybe you guys can inform me if it's a problem. But and so what I have here is I have this API more or less working at the type level, and so I'll show you what this looks like. So this is the sort of a diagram of this sort of test API, where we have these two top level groups. They've got some. Group A has some functions. Group B's got some other groups, which has another group down here, and whatever. It's kind of what you'd expect. We got some groups. Some have groups. Some have functions, and so on. And it all works at the type level. So I'll give you a taste of what these APIs look like. So you create a group. You can add functions to it. Right now they're only queries, but you give them a name. You define the args, define the return.
Is query a union of some strings? Is that like an enum?
Schemas. Yeah. So there are three different types. So in Convex, there are three different types of functions that you can define. You can define queries, mutations, or actions. And queries and mutations are functions that run like right next to the database. And so they run in this constrained runtime where they don't have access to. They basically can't perform side effects other than those which interact with the database directly. So that allows them to be retriable by like the Convex, database, whatever runtime, which is sort of another. It's a cool feature of Convexes but yeah. So basically, they can interact with the database, but they can't like hit
okay, sure. No, that makes sense. I was just thinking from an API level, and I'm not sure if this is the kind of feedback that makes sense. Or once again, I keep saying this here. I'm kind of relatively new to TypeScript, so I don't really know what the best patterns are, if there even are patterns. But what immediately jumped out to me is that query being a string kind of seemed like it was a identifier, like group A, right? Because it kind of fits that style there. Where I would think like maybe like Confect API function dot query dot mutation might make more sense. But that's separate from where you're going. So ignore that.
Yeah. I totally agree. I just haven't gotten to it yet. But yeah, this is a union type of the three strings query mutation action. I agree. I just want the API to be .query. But I don't remember why it ended up like this as I was sketching this out. But yeah. Thank you for the thought and the question. So you add functions. So it looks like this. You can also here's another example. You can also add a group, right? So you can add a function or you can add a group. Pretty straightforward, right? And don't really have to worry about this. It's not relevant to my question. There's also I guess I can just explain very briefly. You also need to be able to pass in the schema, your database schema, so that we can do the type generation and stuff. So that when you're defining your functions, you have access to type safe, like
Okay.
querying APIs,
That makes sense.
database querying APIs. So we need to pass this in as well. So we've got, so here's how you tie it all together. You have your, you make an API, you add some groups to it. This is, I was basically just kind of copying this from the HTTP API modules. And then here is where you implement the API. So again, same API here as in the HTTP API modules. You have this handlers thing. You can handle these different functions for it. So you have to create an implementation for each of the groups, and you can see here that this is all. I think I have the types all working here where. You
that's
get,
awesome. Oh man,
you get
TypeScript.
some
So
help
cool.
here.
So crazy.
Yeah, it's nice, right? Yeah. So you create an implementation for each node in the tree, and again, it's just like the HTTP API stuff that then you provide to the groups that have other like dependencies on other groups. You can provide the implementation, and at the end you end up, and the types also look kind of insane. And so as I see, you all have improved that in some places in the new version of Effect. I have, I would like to do the same. I think I understand how I would do that, but right now it's quite ugly. But in any case, at the end of the day, you do end up with something which has no more dependencies, and that's your
Perfect.
API Live layer, and so that's great. So that all looks like it works, and just have like. It looks like it works, and so then we come down to this point where we need to access the implementations, and here's where I find myself lost. And so there's just one other thing I want to just show very quickly, because this is a little bit different from, and I hope I don't lose too many folks here who haven't looked at the platform code as much as I have, and I haven't looked at it as much as I'm sure many others have.
I've barely looked at it myself, so
but what I'm doing here is a little bit.
I'll be a proxy for the other ignoramuses in the crowd.
Perfect. Okay. So what I'm actually doing, what I sort of tried to do here is a little different. So in looking at the platform code, when you create a group of endpoints for an HTTP API, what happens behind the scenes is something involving a router abstraction, which I haven't been able to fully grok. So I guess my point is that I understand something's going on there, and I don't understand exactly what it is. What I tried to do here is I tried to create. It's actually in this module. I actually have a Confect API group service, so a different type. And so this is when you do Confect API builder.group and you fill it out with all the handlers, it produces a layer whose value is which contains this service, not just at the type level, but also at the value level. It contains an object with these fields, so it has the handlers, and then it's the API. So that's what it looks like. And these handlers are, I guess, the implementation is not that important. So what you'd expect, the stuff's in there that you need. And it's basically the implementation from. It basically looks like how it's done in the platform module, in the HTTP API modules. So So what I need to do is I need to implement this. I need to understand in the context of, so right now this is what it looks like, the implementation here we get, and you don't really need to worry about this. Again, I just need to pass in the database schema to do stuff with. But basically, I'm passing in the layer, which contains all the implementation somewhere, presumably. And I need to figure out how to access them and do whatever I need to do here.
So the hole doesn't work. The hole is
Does that
not.
make sense?
It's a no-opping hole. Dang it.
Yeah, I was wondering whether Effect would have just provided an implementation for any arbitrary program I might write, but turns out that's not the case. Not yet.
Use AI. Nice little the new directive hotness.
Use AI. Maybe this is the
but no,
way
for educational purposes, we'll do it maybe manually. Well, maybe Maxwell, do you have any thoughts?
So one thing, the router in the Effect HTTP libraries, I haven't. The HTTP is Tim's baby, not mine. But I'm pretty sure the router in the HTTP libraries is literally the HTTP router, like the thing that decides where requests go based on the path that comes in. So I'm not sure if you need any abstraction for something like that with Confect, but I believe that that's what the purpose of that is. At some point here, with this make, so make here is getting the schema and it's getting a layer with all of the handlers defined in it, right? And in here, a few things like you may, I'm not exactly sure, like you'll have to test this out because just looking at the types, it's hard to know. But right now this layer is only capable of producing something. But you may actually want to enhance this constructor to also allow other services to be required. So adding like an R, an input services like type generic for the layer that you have there. But I guess the question here is, so this make constructor here is going to need to build the layer for all of these handlers, and it's going to need to, like, I guess start the Confect server, or like, is that what does this thing have to do?
Yeah, right. I didn't explain that well enough. So what it's going to need to do is it's going to need to take the all of the implementations of these functions along with their like paths as defined by switching windows here. Their paths meaning like this, right? And I guess for the sake of our conversation, I just need to produce a data structure that is a mapping of these paths to their implementations. What that involves is it's going to involve basically like running this function, passing in the handler, the function. So this is this path, the handler, and then producing what Convex needs to be able to, deploy those functions.
Before we go even any further than that, maybe we can sort of like take a stab at building the layer and seeing what it produces. Do you have a test like version of this somewhere? I'm assuming the thing that you're showing us is like a test version of this like specification that you're putting together.
Yeah, I have. I got it. I can run TSX and run that test file, and we can see like we can run this function with all that. Okay. So yeah, cool. we're that far along.
What we'll probably need to do is we'll want to. A lot of this code is going to be unsafe, just FYI, but let's try building the layer. So this make function is going to it's going to return Confect API server. What does that look like?
The type here is not actually even quite correct, but again, it's basically, this isn't, I updated, so initially this was just sort of, the API was flat, like mapping of group to function names, and then that's it. So like a tree that's 2 levels deep. But now it should recursively produce. So I can give you an example of what it should look like, I guess. But it should look like, group A, group
Yeah,
D.
I think I'm tracking you, and then it would have like the function name,
function,
and the implementation.
Yeah, like that. Right. That's basically
so
it.
This make method has to either be an effect or a layer or it has, or
right,
something that like we run, right? So it right now it's just returning the Confect API server, but probably like it'll be an effectful thing for now, like something that returns an effect of Confect API server, and then we can figure out how to massage that a little bit later, I guess. And inside we can return a generator from this thing, and eventually this can actually be improved to just be an effect.fn or something like that. But inside this generator, we can let's build the layer. So and just sort of like see what we get back.
So how should I build the layer? What is building a layer entail?
A layer is a graph. Like if we take it a step further than what Kit was talking about today, and we do a piece of education here, a layer is basically a graph of constructors, right? It's a graph of like a dependency tree of constructors of services, right? You construct service A, and then you can move on to construct service B, which depends on service A, et cetera, ad infinitum until you're done with your layer. When you effect.provide a layer to your program, under the hood, effect.provide will build that layer for you. And the process of building a layer is like actually relatively simple. So if you actually, in this generator here, just call like layer.build, and let's look at the signature. So if we take a look at the signature, it kind of tells you everything you need to know. You put a layer in, and under the hood, this build method will take all the constructors, run them to produce the services, put them all into a context, and then spit the context out. So if you look at, it takes a layer in which produces our out services, right? A set of services that we encode here as the generic parameter r out. And when you run this effect, it will produce a context of r out, where r out could be, all the services that this layer includes. And notably, the error channel is all of the errors that are in this layer. Like basically, if the constructors in that layer can fail, that's what the errors are. And also, something to note is that a scope is required here, because layer graphs can contain service constructors that require resources to be built, right? Like you can, when you build a database service, you might need to acquire a connection to the database in order to then build that service. So that service would need a scope, which means that somewhere in that layer graph, there's a service sitting there that needs a scope, right? So when you build a layer, there's like kind of a sequence of steps that happen. And I had a mermaid diagram a while back. Let me see if I can find it. Of like this. I showed it at the workshop.
Showed it the tech days?
Let me just see if I can pull it up locally.
I was there, so I should have.
You didn't laminate it?
I'm shamed.
You didn't laminate? To not exactly. Like, what is this?
No, I printed it up, totally but kidding. Because I didn't laminate it.
Disintegrated.
it get torn up, and
You ate
yeah,
it in an anxious fit.
So
yeah,
effect
yeah.
days.
Tried to consume the knowledge there, and but
Let's see
it
if I
didn't
can
work.
just run this. Hang on. My next flake is building.
I do have a question to be my stupid proxy, the proxy for all, the representative of the dummies. What is that layer we're getting in the beginning? Like, why is there a layer already instead of just like a pure data structure? Like, why do we have a layer to build at all here?
Do you mean
Like the input to make, right? One of these inputs is a layer already, right?
Yeah. So
The
the
API service layer, yeah.
the layer that we're passing, yeah, it's the layer we're passing in. I might not understand your question, but the layer we're passing in is the layer which the API service layer, which itself had or has dependencies on all of the groups, which have dependencies on all of the groups that they have dependencies
I guess I'm wondering, like, why are those layers instead of some other, data structure? Maybe that's how HTTP. I haven't really used the HTTP. I've used RPC a little bit, but I'm not as intimate being newer here. So, is that just how it's done with the HTTP stuff? That everything is a layer, basically.
Yeah, I basically took this approach. So yes, that is the answer I can provide you is because it is like this because that's how Tim implemented this same sort of or solved the same sort of problem. And I also wanted to use. I trusted in Tim's wisdom.
I do as well.
I also
cargo
wanted
cult
to
Tim any day of the week. He's a good cargo god to cargo worship.
Yeah. Yeah, so we're all in agreement that it's neither desirable nor possible to question.
He's in New Zealand. We don't know what's happening there.
I can answer why this is the way it is.
But yeah,
no,
great. Also,
oh God,
also, sorry, just quickly, the other reason I wanted to do it like this. I also just wanted it to be like this because I wanted a familiar API. If people had already used those APIs, I wanted it to be. It would look similar. If you use Effect and you're using Confect, I want it to feel similar to APIs.
Now that Tim is in the chat, he can type out his answer to why you can't nest. What is the rationale for not being able to nest HTTP API groups? While I answer the question of why a layer is being passed in here. The reason and Tim can correct me if I'm wrong since he's in chat now, but the reason why it's implemented this way is because we want to lean into the service-oriented design pattern where your handlers can depend on other services in a nice, clean way. So if we don't do that, if we don't structure around layers, then we are kind of like not leaning into the service pattern anymore. So you could imagine like a group of handlers here may depend on service X or service Y. And if this isn't a layer, it becomes more complex to propagate those dependencies in because you can actually locally erase dependencies for groups and things like that if it's already a layer. If that makes sense.
That makes sense.
Kit.
Yes, I think yes. I mean, you want to make use of the infrastructure that is provided by layers. It gives you certain capabilities, and those are useful in this context. So, yeah.
Tim says that if it was nested, it would get too complex with the layer provision. Well, RJ is about to complexify everything. So, getting back to the layer construction piece of things, let me steal the screen from you, RJ, and I'll put up my
sure
share screen. Don't share the wrong screen. Sure. So I made this little mermaid diagram a while for the Effect Days workshop. I actually didn't get to present on it for very long because I started running out of time because we spent like 25 minutes talking about tag identifier strings. But this is basically what happens when you build a layer. You get a layer, and this is kind of like a diagram from top to bottom that represents the signature that we looked at before, where we have like the layer coming in and we produce an effect. We produce an effect that when run gives us back a context. So really what happens here is you have this layer coming in, and the first thing that we do inside when we, and this is a diagram of what happens when you effect.provide something. But like it runs layer.build under the hood anyways. So the first thing we do is we access a scope and we create a memo map for this like build that we're running. And a memo map sounds fancy, but really all it is just a thing that allows us to put services in to memoize them once they're built. So like we don't rebuild services. So we get access to the current scope and we create a memo map and then we start traversing the graph. The first thing that we do we start traversing the graph, we hit the first service in the graph, we check if it's in the memo map. If it's in the memo map, great, we just keep going, right? We keep traversing through the graph. If it's not in the memo map, then we actually have to run the service constructor. So that's the thing that you declare. Like if you would use effect.service, for example, that's the constructor that you provide. So we run your constructor. And if you've declared a scoped layer, we actually provide this scope to that layer. So we use the scope and we keep like extending finalizers into that scope from these layers. If no scope's required, then we don't have to use the scope. Once the service built, we add it to the memo map, and then again, we just keep going around and around, traversing this graph until all the services are built in the correct order. And then once we're done, once we've constructed all the dependencies, they're all getting put into a context object. So what the end result is a context object that has all of the built services in it. So I think the key here is like layer is like, I always think of it as like a lazy constructor for one or more services, because you can have a layer that has a whole graph in it, right? And the context is just how we box up those one or more services. So when I say like we need to build the layer that you're providing, so maybe you could steal the screen back, RJ, and we can start taking a look at this.
Sure. So a quick question here then. So the context that's produced by the process of building a layer, even if the layer is a dependency graph, so has like isn't just like a single service. The context is still flat. Is the context still a flat mapping of service identifiers to?
I think I actually have an example of like what happens under the hood here too. Yeah, I do. Wait, do I? Yes, I do. Okay, so I have this like simple my service and my service layer pair here, right? It's a service that has one method in it. I'm using context.tag, and here's the layer for said service where I just pass in a dummy implementation. And then in this method here, we create this is one big giant outer effect.gen. And what I'm trying to do here is simulate what happens when you effect.provide a layer. So this is the program we want to run. It depends on my service. At some point, we effect.provide my service layer to this program. And so under the hood, when you effect.provide something and that thing is a layer, we create a scope for you. We build that layer with the scope. So here you'll see like layer.build, we're getting that signature back of like a context. In this case, we just have one service, but it would be a flattened map of all the services. And the scope is required. We just extend this scope to this effect. So we're not closing the scope yet, we're just extending it, which basically does a effect.provide of the scope, provide service of the scope under the hood. And what we get back here when we actually run this thing is the actual context. And then, again, if we imagine we're still in our effect.provide, we provide the context to our program. And then once the program is done, we close the scope. So for like what we need to do, or at least what I think we need to do, is we need to build that layer and sort of see what's in there for us to work with based on the data structures you've defined. So we could
Okay.
try that and like see what it looks like in there.
Great.
Yeah.
All right.
And theoretically,
It's
the
not too
keys
scary.
might be the names of the groups. We'll see. It's like Christmas. Let's see what's in there.
Yeah. Yeah. Okay. Oh,
I'm glad this is vaguely related to my context Flash presentation. Now everyone understands perfectly what's happening.
Yeah. It was not intentionally
Tim wills it. It was willed by
coordinated.
Tim. He smiles upon us.
He smiles upon
Providence.
us.
All right. So
Tim smiles upon us. So maybe to
I don't know. Maybe
simplify
something.
things here so we don't end up with a scope in our dependencies, RJ. Before the build layer piece here, the first line, maybe just do a const scope equals yield scope.make. And then instead of layer.build, let's run layer.build with scope. And then I think that allows you to pass in a scope as the second parameter.
Second parameter. Okay.
Hey.
Okay. Cool. All right. Shall we give it a try?
Let's see what it looks.
I don't know if this is the.
If you wanted to log it with detail, you could do a console.dir, which will run util.inspect under the hood. Console.dir. And then instead of the JSON.stringify, do depth null, and then also do a comma colors true. So this will run like nodes util.inspect under the hood.
Okay. All right. Let's see here. Let's copy the path. And oops, that's not there. What?
To be clear, I'm not the one tagging Dylan in chat. That's Kit. But it's showing as my name.
To be absolutely lucid, it's Maxwell tagging Dylan in chat.
You probably need to run this effect now. Where
Yeah, makes sense. I guess this is going to be an effect now. Yeah. So,
okay.
How do you see who's in the chat? I don't even know how somebody realized that Dylan was here. We're just the humble producers.
there.
Okay.
Okay.
Oh, this is fun. Look at all this stuff.
So
we can always simplify the test, API.
Maybe we would want to go down to just one layer of groups, to heed the smarts fence. But no, this is. I mean, what do you see, Max, when you look at this? Does it bring you joy?
One thing. Can you go back to the actual program, RJ?
Yeah.
So.
Yeah.
So this is. To me, it looks like this is a layer, or we're producing a context map. It looks like we're producing a context map that has the spec inside of it. Like, if you go back to the log, wherever it was, I don't know where it was. This looks like the spec itself, like the.
Yeah.
But should this not be a context of the handlers?
Yeah, it should be. Let's see. So what it should be is, let's look at this real quick. So we're passing an API live here, and yeah, it should be. Let's look at group here. Yeah, so group should be. I mean, maybe there's some issue here. This is obviously kind of a lot to look at, but yeah, I mean, it should be producing. So you can see I'm when you call group here, I'm returning this, so the API name and
so if we go back to the log, then do we
the
see API name and
Zoom.
handlers nested many times? If we do, then
no, I didn't.
I see API name at the very top.
Yeah, that's right. That's for the API service. There. Yeah, but no, I don't see the handlers.
Instead of calling provide, can you call provide merge? This could be like.
Yeah. Yeah. You mean in all of the places where I provide?
Yeah, I'm just
these,
confused why
like
these things are not ending up in the context. So maybe we could just try provide merging them.
Because provide doesn't add it to the context, right?
I can't remember. It doesn't on the type level.
I see.
Which means it shouldn't on the runtime level, but I honestly can't remember.
Yeah. It didn't in Zio, unless you merged.
We can try running this now and seeing if we get stuff.
It's clear.
Nada.
Wait.
There's more stuff. Oh, here we go.
Yeah, there you go.
Items.
Some handlers here. Okay.
Cool. So there's things.
Yes, there are things. Yeah, the right things. It looks like
there are 6
in some
things
cases
in here.
Yeah. Yeah. Maybe I should just we should just simplify this for the sake of.
And I think maybe this is what Tim was talking about with like nesting too many levels. But I think the reason why it allowed us to do that was you may be missing requirements on the type level, RJ. So when you add a group to the API, when you actually make said API, the R channel should include a requirement on the handlers for every group that's been added to the API, so that unless it's been provided, I guess. The problem here is that calling layer.provide doesn't add it to the context, whereas provide merge does.
Okay.
Yeah.
So I'm fairly confident that at the type level, this is working as expected. In terms of, I mean, so you can see the signature here for group. I mean, unless I'm misunderstanding what you're saying or something else. So we have, the service that gets service for the layer.
I think this
and then
is
we
working.
Have
it's what I'm saying is that if you go back to your test,
okay.
So the top level. So take at the very bottom where you actually make your API, take away the provide merge group A live. Take that away.
Just like this.
So here, we're not getting a type error currently. Right? Is this the spec or is this the implementation? Oh yeah, we are at the bottom. We're getting a type error at the bottom.
Right.
And the reason being is this is going to be a very large type, but Confect API group is not assignable to never, right? So if we comment back in group A live right now, the type error goes away, but what does group A live provide?
A very also a large signature, but it provides, I guess, this.
Yeah. So the problem here is that your spec. So if we go to wherever the spec is for this, the API here, yeah, your spec requires Group A to provide implementations for everything all the way down to Group BDE, if I'm not mistaken, right? If you go to their diagram at the very top. Or sorry.
Yeah, I think the Group B actually is one that has these deeper dependencies.
The deeper dependencies then. Go to the bottom and actually wait, no, this we don't even have to test it. It's API with database schema right now has everything, right? That has like all of that has the full spec that we defined in that little diagram up at the top, right?
Yeah, or API.
And we're adding Group A and Group B. But you can see there's a problem with the types here just by scrolling back down to the bottom. We're not providing Group B,
right? I see,
and it's type checking. So there's a problem here.
Yeah.
I noticed that the reason why I this clicked sort of quickly is because provide versus provide merge. There's a semantic difference in the way the types work, right? Provide merge propagates those inputs out. Provide does not, but both are type checking, which is a problem.
Right.
So you're getting everything you need, I think, in the output of building the layers. In that context object you get back, that map has all of the 6 handlers or whatever it is that you need. But there's still a problem with the types. And I think maybe this is what Tim was getting at with saying like nesting more than one level deep gets really complex, and maybe this is what he was referring to. I'm not sure. We should just have Tim like join these calls once he signs in, but it is also really early in New Zealand right now. So, but I think that one thing to fix, I think, would be making sure that those types work. Once those types work, the key here is going to be, you're usually at the office by this time? Jeez, that's early. Sorry, I'm like talking to Tim in chat and you guys in the video at the same time. One of the things that, after the types are fixed, right? One of the things that you'll need to do in your make constructor is get all the handlers and then decide like what you need to do with them. So I'm not exactly sure like what needs to happen at this point for Confect. Like I don't know what needs to happen. But here you've got a context object that has theoretically all the things that should be there. Once the types are fixed, like the context here should have everything that you think it is.
Well, to be pedantic and just to make sure I understand, it even with the types being broken, it still contains
you just can't be like sure of it because right now we could run this again right now and the types are checking, but we don't have everything we need.
This is kind of what I was alluding to before with the implementations of these kinds of libraries. And now you are implementing library code, so you must now bear this burden, which is there's a disjoint between the type level and the runtime level. And if you're a library author, you basically just have to make really sure that those things are kind of smushed together. But that's the fun stuff. I mean, some people hate this stuff, but I don't know. I like it. It's very challenging. It's a lot of work. But then at the end, you have a beautiful API.
The nice thing is a context, like you can access the map of a context, like just by, so a built layer here. If you go, you can even change this to context because that's what it is. It's going to be your context object, and you can access the map in an unsafe manner just by doing context.unsafemap, which is the prop, like just hit enter or O or whatever.
Like context module?
Like the variable here.
Dot unsafe. Okay.
So you see unsafe map. Unsafe map is our unsafe interface. It's basically what Kit was showing before, the map of string of any. So here you can actually like manipulate stuff now, right? You can invite me then. Invite him, Kit. God.
I think there's a call-in button. I sent you a link on Discord though, Tim.
So here you can do whatever you need with the stuff that's actually in the map now, right? So if your keys in the map are what you need them to be, you can build the data structure that you want out of this.
Right.
Now.
Gotcha. And so is this how you would recommend, maybe Tim can also advise, I go about this and then just access the kind of type unsafe map here? And
it kind of depends on what you need to do, right? If you need to do unsafe things, like if it's going to be more laborious to work with the type system, like taking one step back. What Kit said before is absolutely true. Like when you're implementing library code, sometimes the type system just sucks to work with, because you can't.
Yeah. That.
I think that it's going to depend very heavily on like if the types of if the types of context give you everything that you need to do what you need to do, then sure, use it. That's fine. Then at least your stuff is type safe. But like if you need to drop down to type unsafety, that's also fine.
Hello.
Ciao, Tim. Welcome.
Ciao.
We have uttered your name
I haven't
many
really
times
been following
today.
along. I've been working.
Well, so yeah. Well, I was just going to say. Well, I don't know. Go ahead. Maxwell. I was just going to try to frame the questions for Tim.
I'll give you the data dump, and then you can provide any additional context you want. But so the long and short of it is, RJ is building a effect-based API over the top of Convex, and he is exposing an API that is reminiscent of the HTTP API Builder API, with the significant difference that his version that he's building up here, he wants it to be able to be arbitrarily nested. So if you scroll up to the top, RJ, you can sort of see this diagram. Like this is kind of like arbitrarily nested handlers. And with, I don't know, Tim, did you ever experiment with Convex? I've had a little bit of taste of it.
No, I haven't used that before.
Basically the API exposes, I'm going to just quote RJ a little bit, you can do queries, mutations, and actions. So these Confect API functions can be either queries, mutations, or actions, and they'll declare like their own name, their schemas. It's basically the spec. And then you're building up the implementations for said functions by implementing the groups. So we were just talking about one issue with the types, which I think RJ will look into, but what we were really focused on was like the actual point at which you've built up your spec, you've built up all your layers, and now you want to actually make this into something that can be used by Convex. So RJ was kind of like, if you flip over to the like make method, RJ, this is the point at which you're passing in your spec, so your database schema, and you're passing in your layer that has all of the implemented handlers for your functions. And then we were basically just talking about like how you can actually get access to those implementations.
Right.
So here we were literally just building the layer and looking at what was inside.
There's usually like a couple ways you can go about it. One is having like a registry service, which is just like a glorified map that tracks everything. And that in itself is just another service, but it's a registry. And then the other layers like add stuff to it. Or you can like just stuff everything into the context and use the unsafe map method, where you have like a kind of like you have a well-known prefix that you kind of like search for in the context, and you just pull out everything that matches that prefix.
To distinguish the like user provided.
Or you can do like what RPC does and has. Oh, that's what RPC does. But if you're like capturing string identifiers, then you can like target those.
Mhm.
Yeah, like you could, if your spec can be built into a data structure as well that has identifiers associated with them, you could use those. Like in the AI toolkit, Tim and I sort of like built it in such a way that the tools that you add to the spec carry an identifier for the tool. So like when you need to access the context later to access those tools, you can just use the identifiers from the spec. And since you have the spec here, like if you want to build the stuff in the context into some other data structure that's usable by context, that's usable by Convex, you could use the spec, your schema here maybe, if it has identifiers that you can use to access stuff in the context. So there's there's a bunch of different ways you can go about it. What do you actually need to return again here, RJ? Like, is it something that Convex needs?
Well, so Convex,
Like, how is
I'm going to have to build
this
another
intended to be used? Basically, like once you've produced Confect API server, like how is this intended to be used?
Yeah, so I think that what I'm probably going to want to do is have some CLI tool running like a. I'm going to need to generate code. I'm going to need to generate some code basically because it's not possible to provide the Convex like dev CLI expects that you export your Convex functions. It picks them up as like exported functions from modules, like so it like reads the file system. You can't provide like a single data structure by means of like in TypeScript by means of some API with like your whole API. So I'm going to need to do some kind of code generation. Yeah, and I haven't come to that step yet.
I think in general it can be really helpful and informative when dealing with anything that like this abstract. I mean, I ran into this a lot doing macro programming, but this is kind of the same problem. Macros obviously here with any sort of like really abstract DSL where it can be nice. It can be very simplifying and orienting to start with like pretend you didn't have the DSL. Like, yeah, what is that final artifact? What is the target that you're targeting, right? And then because that might limit you, that might give you ideas. It might say like, one quick question then is like, so if you're generating something that has to be picked up by the Convex CLI, is that even going to be possible? Like what information, what's like the raw input? Like I like to think of everything. The one thing I like from functional programming is thinking in functions. Like what is the input, what is the output? And just sort of doing that at many levels. So like, what is the target output here? And then what is the simplest, like just zooming into that last step of this chain, what input would be most convenient for you to have in scope without worrying about some crazy DSL that would generate that for you? Just like, what would it be really nice to have at that last level to generate the thing that Convex needs?
Yeah, I think if I was going to I'd be working backwards from what Convex expects and trying to remove the code gen. Because when you start adding more layers of code gen, it becomes really annoying. And ideally, you would just compile your TypeScript and you have your artifact. So maybe using like the HTTP API approach isn't the best for Convex, but I don't know.
Well, so yeah. So I think that there may be different ways that. So I guess what I'd always been imagining is that sort of whichever way, however I get, like at the end of the day, I'm going to have these convex functions, these convex function like definitions, right? I'm going to have the validators that they call them validators. So I'm going to have the schema, the spec basically, right? And then I'm going to have the handlers, the implementation. And I just want those. I want a collection of those, and I want them to be this collection to be keyed somehow on, or just paired with their path. So their name should be a path because that's what Convex expects. And so by path, I mean, like group A, group AB, function A,
That makes
or
sense.
whatever. So I think that regardless of whether I do some kind of like code gen or whether I find some other approach, like at the end of the day, I need something out of this make function that looks like, that looks like this.
Right. I mean, it's another way to think about it would be like, even just because right now it's this like map structure, but even just like if it's an array of like, what is each element in this array? It's just like you have the path, the schema, and the handler, basically. And you have a list of these. So that's a good place to start. That's kind of what I meant, but that like last link in the chain. If you had that, then you can focus on, we'll worry about how to generate that array or that object later, which obviously would be what this DSL does elegantly, and work our way back to that nice, well, burning the candle from both ends can work too in this regard. But yeah, how would you, I'm just curious for myself, like what is the step, if you did have all this stuff easily accessible, what would be the next step to let Convex use it? Because you could generate some new file that has like the paths and maybe something generated from the schema definition, but obviously the functions are going to be opaque. So how would you call into those sort of runtime function values? I could be confused.
Yeah. So the way that so I guess to reiterate, the way that Convex works is it expects you to have a directory that contains folders and ultimately files, which export what they call registered functions. And so that looks like concretely, there's registered queries, mutations, or actions. And, of course, they're checking that. So yeah. So there's that, right? What the Convex dev CLI does is it reads all of the files in this directory, and it reads all the exports, and, it checks for, there's some kind of like value, like, I haven't looked too much into the details of exactly how it works, but something like they check to see whether it has maybe an attribute. This attribute is convex function on it with the value of true or something, and then it'll process it as though it'll assume sort of the rest is a function that it can process, and it can upload the code and deploy it to your backend. And it deploys it at it gives the identifier for that function is derived from the path of that function in the file tree of the directory that you specify contains your convex functions.
So would the idea be that?
Does that make sense?
So you would code-gen the structure based on that static information that we just talked about. And then in terms of calling it, maybe that whatever is code gen, the final terminus, that leaf node of the actual function, would call into this server, which would then once again do the routing into the handler, because the handler couldn't be code gen, right? Because it's a function that you have as part of this DSL, so you couldn't get the actual code that ran the function, but you could have that run something that this code gen function can call into with its lookup information, if that makes sense. I mean, maybe, I don't know, maybe, does Convex, sorry, this is like a tangent, but feel free to pop this off the stack right away, but clearly their CLI calls into something that they have control. I don't know if they expose that to the public, right? But maybe it is possible to, like as Tim was saying, collapse a code gen. But anyway, that's how computers work. It's code gen all the way down, really. Transpilation after transpilation. Yeah, that's so. I don't know that I completely followed what you were saying, but I think that maybe this will still response to the thought. I think that one way I can imagine doing this is just taking this object that I produce here with the not here here through make. And generating files that just basically, you imagine
this is a new file, and I like import, made server, right, from wherever, and then I do made server dot and then the path, like path to registered function, and like leaf, like function name, right? That might be sufficient. And then this is going to be, and I guess the key point here too, right, is that like I'm going to give Convex what it expects here. So I'm going to be giving it. I'm going to sort of like, this is a serverless like platform, right? So there's no, each of these functions is going to be doing like effect.run promise or whatever, right? It's gonna execute the effect. Each function is gonna terminate in that, right? So so then Convex should be able to hoover this up, and then I should be able to use the fact that I know what the path name is because I generated it on the front end to then hit the Convex API, and know that and hit this API with made server.path.toRegistered function, and know that it requires because of the spec, right, that I created, that it requires these kinds of arguments and do the encoding on the client, right? Just I mean, again, I imagine how RPC.
Yeah, no,
HTTP,
it sounds like it's possible
HTTP,
then.
right?
A little awkward, obviously, just due to the requirements of Convex, but nonetheless, like it sounds like it is technically possible. Yeah. There's a way to do it. I would recommend, I think, just nailing that part down first, just to ensure, like, it sounds like you have everything you need, but just really make sure that given this like hard code, one of those shapes, like a path, an effectful function, and the schema, and just start with that codegen bit, and because that'll pipe into the rest, that'll compose with all this other DSL stuff later. Like you'll figure out how to generate that later, but I guess fail fast, right? And then maybe that'll force a slight redesign too. But yeah, working backwards, at least at the beginning, is helpful, and then you can work from the very beginning too, and kind of meet in the middle. But just starting from the top and working your way down, you might end up a few miles off from your target. But yeah. I'm not sure if we fully solved your questions today. It's a really fun exercise.
No, well, I mean, I think the main question I needed answered is sort of like what happens. I mean, like I didn't know I should be using this build function to break down to get the context from the layer that I've constructed. So like this was really the answer to this is really the main question I had, and I think this is the answer. I guess the only other question I would have is whether, Tim, whether you think that the idea of having, and I know I'm sure you haven't been following this conversation, so, but just that having nested groups, like that isn't a really bad idea for some reason, and will serve me very poorly.
It might start getting hairy when you consider things like middleware. Because then if you have like nested groups, then middleware needs to apply to the child groups and that kind of thing. So you need to think about where does it get provided, and so everyone can find it. And it just starts getting a little bit complex. Like, where do I provide this layer? How do I compose them? So I didn't really go down that rabbit hole for HTTP API just because it starts getting really messy.
Yeah,
I would like.
It makes sense.
Go for it, kid.
I would like to, for next week, if I have time, maybe try to prepare something like a very miniature toy version of sort of this pattern, as well as maybe the registry pattern, I think, that you mentioned as an alternative, Tim. Sounds like it could be just, I mean, I would like to have a good concrete grasp of how both of these patterns work, and just be able to like reproduce it quickly, maybe with some animated slides or something. To if anyone is feeling lost with how these all hook together, because it's really cool. I mean, the end user experience is nice. Looking at the library code, you're like, I never want to write code like this. Well, luckily, that's because only Tim has to suffer in this way, and Maxwell and RJ. But the rest of us get to reap the benefits on the call site. Anywho.
Probably one thing, I'm just looking at this code now, you probably need to consider like the memo map, whether that needs to come into play. Does this return a layer? No, it returns an effect. Okay.
Yeah, at the moment. Obviously, this is very.
And the other thing that we
implemented,
haven't done here, just something to consider for the future, is how this scope will close. Because right now it'll just stay open forever, which means that like resources that expect to be cleaned up at some point won't be, because the scope we're never scope.closing that scope. So just another thing to like consider.
Yeah, and it does sound like there's sort of two uses, right? There's sort of the build step where you are going to code gen these different files, and then it's also going to double as the thing you can call into from the code generated files that'll actually execute the handlers. So there's sort of the construction, the code gen, and then the actual execution. So that might mean you actually want to generate something. I don't know if the word server fully captures the different things it's doing a little bit. The naming is hard, but it sounds like there are these two interpretations of the same data structure that you'll need. But yeah.
Yeah, agreed.
Well, very cool.
Very cool.
Well, thank you. That was very helpful. I hope it made sense, made enough sense to folks, and was interesting.
Oh
enough.
yeah, totally.
I
mean,
cool. Yeah, and if anyone has more thoughts, suggestions, or questions for me, I'm happy to.
Hopefully nerd sniped or nerd shotgunned some people. So you can hit multiple targets, I guess. But anyway, in the audience, and they'll help out. And I know it's open source, so search for Confect. I think that's probably the only combination of the words convex and effect on GitHub. So yeah, make some PRs, make it production ready, etc. And yeah, I'm very curious. I'm nerd sniped in that I want to figure out how these APIs work. The HTTP group stuff. So I'm going to implement something, and maybe that'll give me some ideas to help you out next time, RJ. I'll reach out if I come up with anything.
That'd be great.
But yeah, I don't know. It's been an hour and 40 minutes. Are you guys shifecting tonight, Tim, Maxwell?
I don't know. We got to talk about it offline.
I hear the Call of Duty in the background, Maxwell. I think.
My son is not currently happy, so.
He disagrees with our approach, I think.
Yeah, disagree.
But he has any
with
ideas.
every approach.
Let me know.
Except for feed me.
All right. Well, I think that's a good wrap for today's office hours, and we'll come back next week earlier, 10 a.m. Eastern time. Ask an AI to translate that into your time zone. It's a hard problem. But yeah, thanks for stopping by. And Tim, great to see you. Come whenever. Well, I don't know. That'll probably be too early for you. I didn't think about optimizing for New Zealand time. That'll be in the middle of the night.
I usually arrive at the end of the allocated time slot.
Okay. Cool. So you'll be dead asleep in this new time zone. So maybe if you want to astrally project in, feel free to do that. And I'm sure we'll try some other time zones. But yeah, see y'all at 10 a.m. next week. Thanks for stopping by again, RJ, and call in again soon. And take care, everybody.
Thanks again.
Peace.